Mars. For centuries, human civilizations have noticed the red giant in the night sky. It is the planet closest to Earth at only 225 million kilometers and has great possibilities for exploration. In January 2004, NASA's machine, the Mars rover, landed safely on Mars and began taking pictures of the environment. The next big step we must take is colonization. With the right science, the right funds, and the right people, we believe it is possible to have a functional colony on Mars. Since we are already running out of non-renewable resources on Earth, it makes a lot of sense to head to Mars and search for them. Additionally, water has been recently found on the surface of Mars. We will be able to use this water not just for drinking water, but for research opportunities. And talking of research, science opportunities will come up frequently in all fields. The next step is deciding who our best choices are to be our colonists. Colonist applicants must be over 18 years old and will be chosen based on a certain set of standards. Our future colonists will be chosen based on their academic experience. This includes their school-university background as well as their grades concerning topics they specialize in. Health is an additional primary concern. A healthy citizen with all vaccinations and little to no hereditary diseases would be in our favorings. When people apply to become some of the first Martians, having no criminal record is something we take concern in for the others' well-being. Lastly, we want to include diversity on Mars, so we will be choosing people of different nationalities and an even amount of men and women. Step number 3 is actually reaching the red planet. The spaceship you see here is the most recent design for a spacecraft known to man, and is very similar to NASA's guidelines. It is very large, has a stable engine, and will be piloted by very carefully picked, experienced astronauts. It will get our colonists safely to Mars despite the 225 million kilometer journey. It is expected to take 9 months to get to the Mars, as our spaceship's average speed is 17,500 miles per hour. Additionally, on Earth, the gravity pressure is 9.807 ms squared, while on Mars it is only 3.17 ms squared. The spaceship's design is perfectly formatted so that our colonies will arrive safely on Mars and not be in shock while landing because of the difference in pressure. For our fuel, we will use solid propellants for the first stage to depart from Earth. Then throughout the next 8 months, liquid hydrogen and oxygen will be used to reach Mars. And then, once we are close enough to the planet, we will use liquid propellants. Once our colonists arrive safely on Mars, they will settle into their new home. The structure of the Mars colony headquarters will be a confined, larger, central dome with a breathable and livable atmosphere. The center dome will be attached to several smaller domes. The larger dome is meant for vocation and communal activities, while the smaller outer ones are meant to be living quarters for individual colonists and colonist families. Both large and small domes are made from the toughest plexiglass known to man. About 5 inches thick, they are lined with reinforced concrete at the bottom and steel to encase the linings. This is all to keep the glass structured and seal tight to keep the atmosphere balanced. Since dust storms and high wind pressures are a great concern, as well as the glass, other materials will be able to resist the harsh and unpredictable weather patterns. Harmful radiation will be blocked by high-density materials such as aluminum to reduce the intensity of the radiation. This is all to keep our colonists safe, as radiation is very harmful to the human body. The central dome is where the colonists will perform their jobs and socialize with other colonists. It has endless vegetation for ample oxygen outtake and carbon dioxide discharge. The inside of the dome has many transportation roads, walkways, and panels indicating locations. The dome has various windows so colonists don't feel cooped up or have unbalanced sleep cycles. Additionally, the absence of light can cause emotional and/or physical health imbalances. The exposure to the sun through the windows will help with human health all around. Furthermore, plants not only provide oxygen but provide a familiar environment so colonists aren't shocked from the sudden change of environment either. Since the dome is also quite large, walking around will provide exercise for the new Martians. The large dome also serves as an activity center for children as well as adults. It has a park, sports center, and many other activities. Our colonists' living quarters would have very similar setups to those of the homes that might be on Earth. Hallways would break off from a small foyer and lead to other rooms, such as a kitchen, a communal room, 2 bedrooms, and a bathroom. In addition to all necessities, homes would be equipped with necessary appliances like heaters, coolers, and oxygen suppliers. Oxygen-generated systems, the oxygen suppliers, work by combining water and electricity to remake oxygen. NASA uses this machine aboard their space station too. Houses will have a modern look that look very similar to those on Earth as well. It will be very modern and contemporary. The living quarters will also have some windows as to not be too confined looking.
Now that we know what the colonists are going to live in, the next question is where. Location was chosen based on weather patterns, where it would be easier to build, and how safe it would be for the colonists. We hypothesized that building the domes on a plain would be our best option, for it is a flat surface, which means it is easier to build on. The wind and weather patterns are smoothest, and it is safe from any collapsing of mountain or craters, which is more common than you might think. So building on a plain or stretch field would save money, time, and not compromise the safety of the colonists.
The food growth stations will provide research opportunities for our botanists and agronomists, as well as provide extra food sources for the colonies. Even if the sun is much further away from Mars than it is from Earth, we will bring Earth's soil, keep it indoors with additional water, and tend to it carefully so crops can be grown. Though in the beginning these food growth stations won't be able to support the entire colony, over time it will be able to sustain the colony with a plant-based diet. Water circulation is important because before water can be drank by colonists and water plants, it needs to go through a water decontamination machine to separate settled water and solid contaminants. Water will be brought from Earth every 10 months or so. Additionally, water that has been found on Mars can be studied and brought back to the laboratories. If we find enough water and a way to get to it, in a few years, that water could be used for drinking. Though because of all the contaminants and solids, the water would also have to go through the decontamination system. Water is circulated through the domes by circulation and the decontamination system. The water that travels from the base goes to a storage tank and parts off to the living quarters. The communal domes and the food growth stations have that as well. Once everything is set up and our colonists are living life as planned in their new home, we must have an escape plan. If any of the following occurrences indeed occur, there will be an emergency evacuation drill, which all law enforcers are aware of. They will lead colonists to the emergency spaceship that is identical to the one that first brought the colonists to Mars. Once the ship departs, the crew will fix any of the problems as soon as possible, and if the colonists wish to return, they may. If not, they will be replaced by newly trained colonists.
Every 10 months, a shipment of food and water will be dropped off at the domes. Emergency products such as medicine, machines, and repair crews will be sent as well if they are needed. Every 2 years, 40 more colonists who are specifically chosen for the Mars project will be sent to expand the colony even further. To better adapt, more living quarters will be installed as well. Lastly, yearly vaccinations, physicals, and mental health examinations will be done on all the inhabitants to make sure that everyone is healthy and well.
In the end, we will want to have 500 colonists to complete the colony. Mars does indeed have seasons that are similar to Earth's. Mars' seasons are caused by the tilt of the axis, which is also the case for Earth too. Its axis is tilted 25 degrees, while Earth's is tilted 23.5 degrees. Spring lasts about 7 months, summer 6 months, fall 5 months, and winter just over 4.2 months. Mars is also a planet with temperatures that are much lower than Earth's, because Earth is about 92.96 million miles away from the Sun, while Mars is 141.6 million miles away. The temperatures on Mars have been known to reach 130 Kelvin or negative 225 degrees Fahrenheit. So although the 4 seasons are very similar, the temperatures on Mars are much colder. This is another reason for our domes to be made of reinforced concrete, steel, and plexiglass. all of which have a good reputation for keeping heat in and cold out. The temperatures also stay the same throughout the year on Mars's equator. Now that everything is settled on Mars, there is one last issue we must tackle, and that is energy. There are constant winds on Mars, which means we will be able to use windmills to convert the strong winds into energy. This is cost efficient as well as energy sufficient, for it is proven that wind is the most effective renewable energy source, more so than hydroelectric power or solar energy. After the large amount of winds, the excess energy can be stored away in generators that will be placed in the domes. In fact, wind is so constant on Mars that it would be more reliable than fuel or oil would be on Earth. Of course, once all is functioning in the colony, our colonists will surely want to explore the new world around them. For this, our labs have designed a transport vehicle that can take colonies out and about on the Red Planet. The transport will be made of aeroshell, a material that is put on the outside of spaceships that can keep temperatures even, resist strong pressure, and most importantly, is light enough so that transport may go at a reasonable speed. The transport also has weight-pulling abilities if something needs to be transported, as well as 6 wheels to stay grounded. 4 people can fit comfortably and breathe normally inside the vessel. Mars was once a great and beautiful planet out of man's reach. For centuries we have wanted to set foot on the incredible frontier. We are glad to say it is no longer an impossibility. So let us go to Mars, for the advancement of science, for the sake of exploration, for the knowledge of the unknown. Let us go to Mars, so our greatest hopes for the future can become our greatest moments in history.